AMD keynote, which started at 6:30 p.m. roughly. I learned the hard way that arriving at least 2 hours early is essential for these keynotes. We headed to the parking garage, which became crucial for my CES week and future events. Parking cost $20 at the Palazzo, and I realized it could serve as a central hub for navigating the convention areas. After parking, we proceeded to the Palazzo ballrooms to locate the AMD keynote suite. The walk was lengthy and somewhat confusing, but we successfully reached CES check-in, which was quite efficient. On our way to the ballroom, I noticed various companies like Gigabyte, MSI, AGI, and Thermaltake. We arrived at the 4th floor for the keynote around 4:40 p.m., well ahead of the 6:30 p.m. start time. I mingled with fellow attendees, meeting Chris Mizo and Frogboy X1 Gaming. I began live streaming, but unfortunately the internet connection at the Venetian was poor, affecting my experience for days to come. After about an hour of waiting, they started allowing us inside. I continued live streaming as I made my way to my seat, capturing photos of the stage as I anticipated the show. Dr. Lisa Su made her way on stage, and she emphasized AI's significance as the most impactful technology in the last 50 years, set to become as indispensable as cell phones and the internet.
Today, I'm incredibly proud to say that AMD technology touches the lives of billions of people every day. From the largest cloud data centers to the world's fastest supercomputers to 5G networks, transportation, and gaming, every one of these areas is being transformed by AI. AI is the most important technology of the last 50 years, and I can say it's absolutely our #1 priority at AMD. It's already touching every major industry, whether you're going to talk about healthcare or science or manufacturing or commerce, and we're just scratching the surface. AI is going to be everywhere over the next few years. And most importantly, AI is for everyone. It makes us smarter. It makes us more capable. It enables each one of us to be a more productive version of ourselves. And at AMD, we're building the compute foundation to make that future real for every company and for every person. Now, since the launch of ChatGPT a few years ago, I'm sure we all remember the first time we tried it. We've gone from 1 million people using AI to now more than 1 billion active users. This is just an incredible ramp. It took the internet decades to reach that same milestone. Now, what we are projecting is even more amazing. We see the adoption of AI growing to over 5 billion active users as AI truly becomes indispensable to every part of our lives, just like the cell phone and the internet of today.
She discussed the necessity of cloud infrastructure for training large AI models and delivering real-time intelligence was discussed, showcasing AMD's MI455 accelerators and Helios rack-scale platform.
The cloud is really where the largest models are trained and where intelligence is delivered to billions of users in real time. For developers, the cloud gives them instant access to massive compute, the latest tools, and the ability to deploy and scale as use cases take off. The cloud is also where most of us experience AI today. So whether you're using ChatGPT or Gemini or Grok, or you're coding with copilots, all of these powerful models are running in the cloud. Now, today, AMD is powering AI at every level of the cloud. Every major cloud provider runs on AMD EPYC CPUs. And 8 of the top 10 AI companies use Instinct accelerators to power their most advanced models. And the demand for more compute is just continuing to go up. Let me just show you a few graphs. Over the past decade, the compute needed to train the leading AI models has increased more than 4 times every year, and that trend is just continuing. That's how we're getting today's models that are dramatically smarter and more useful. At the same time, as more people are using AI, we've seen an explosion over the last 2 years of inference, growing the number of tokens 100 times, really hitting an inflection point. You can just see how much that inference is really taking off. And to keep up with this compute demand, you really need the entire ecosystem to come together. So what we like to say is the real challenge is how do we put AI infrastructure at Yotta scale? And that requires more than just raw performance. It starts with leadership compute, CPUs, GPUs, networking coming together. It takes an open modular rack design that can evolve over product generations. It requires high-speed networking to connect thousands of accelerators into a single unified system. And it has to be really easy to deploy. So we want full turnkey solutions. That's exactly why we built Helios, our next generation rack scale platform for the Yada scale AI era, putting some of the tasks from the GPUs. Now, we are at CES. It is a little bit about show and tell. So I am proud to show you Helios right here in Vegas, the world's best AI rack. Is that beautiful or what? Now, for those of you who have not seen a rack before, let me tell you, Helios is a monster of a rack. This is no regular rack, okay? This is a double-wide design based on the OCP Open Rack Wide standard developed in collaboration with Meta. And it weighs nearly 7,000 pounds. So, Gary, it took us a bit to get it up here, just so you know. But we wanted to show you what is really powering all of this AI. It is actually more than 2 compact cars. Now, the way we've designed Helios was really working closely with our lead customers. And we chose this design so that we could optimize serviceability, manufacturability, and reliability for next generation AI data centers. Now, let me show you a few other things. At the center of Helios is the compute tray. So let's take a closer look at what one of those trays look like. Now, I can tell you, I probably cannot lift this compute tray, so it had to come out. But let me just describe it a little bit. Each Helios compute tray includes 4 MI455 GPUs, and they're paired with the next-gen EPYC Venice CPU and Pensando networking chips. And all of this is liquid-cooled so that we can maximize performance. At the heart of Helios is our next-generation Instinct GPUs. And you guys have seen me hold up a lot of chips in my career. But today, I can tell you, I am genuinely excited to hold up this chip. So let me show you MI455X for the very first time. MI455 is the most advanced chip we've ever built. It's pretty darn big. It has 320 billion transistors, 70% more than MI355. It includes 12 2-nanometer and 3-nanometer compute and I/O chiplets, and 432 gigabytes of ultra-fast HBM4, all connected with our next-gen 3D chip stacking technology. So we put 4 of these into the compute trays up here. And then driving those GPUs is our next-generation EPYC CPU, codenamed Venice. Venice extends our leadership across every dimension that matters in the data center. More performance, better efficiency, and lower total cost of ownership. Now, let me show you Venice for the first time. I have to say, this is another beautiful chip. I do love our chips, so I can say that for sure. Venice is built with 2-nanometer process technology and features up to 256 of our newest high-performance Zen 6 cores. And the key here is we actually designed Venice to be the best AI CPU. We doubled the memory and GPU bandwidth from our prior generation, so Venice can feed MI455 with data at full speed, even at rack scale. So this is really about co-engineering. And we tie it all together with our 800 gig Ethernet Pensando Vulcano and Selena networking chips, delivering ultra-high bandwidth as well as ultra-low latency, so tens of thousands of Helios racks can scale across the data center.
Greg Brockman, president and co-founder of OpenAI, joined to discuss AI's evolution, the soaring demand for computing, and its life-saving capabilities.
55 and Helios is actually, a lot of it is through some of the feedback from our engineering teams working closely together. Can you talk a little bit about that infrastructure and what are your customers wanting and how are you going to use MI455?
Well, one of the key things with how AI is evolving is thinking about the balance of different resources on the GPU. And so we have a slide to show how we've seen the evolution of this, the balance of resources across different MI generations. So you see this slide that I very painstakingly put together. Actually, I did not painstakingly put it together. I asked ChatGPT to go create the slide. And so it literally did all the research, and you can see some sources at the bottom. And it actually went and read a bunch of different AMD materials, created these charts, put together the title, put together all these headers, and produced not just an answer for me to then go do a bunch of work. It produced an artifact that I can show. And this is just one simple example that you can do today with ChatGPT, right? That we are moving to a world where you are going to be able to have an agent that does all this work for you. And for that, we're going to need to have hardware that is really tuned to our applications. What we have in mind is that we're moving to a world where human attention, human intent becomes the most precious resource. And so that there should be very low latency interaction anytime a human's involved, but there should be an ocean of agentic compute that's constantly running, that's very high throughput. And these two different regimes of low latency and high throughput yield a bunch of different pressures on hardware manufacturers such as yourself. So it's a pleasure to be working together.
We like building GPUs for you. That works well. Lastly, Greg, let's talk a little bit about the future. Paint a picture. One of the things that we've talked about is there's some people out there who are wondering, is the demand really there? Can AI compute? Do we really need all of this AI compute? And I know you and I have talked about it. I think people don't have a view of the future that you see. I mean, you have a special seat. So paint the world for what this looks like in a few years.
Well, looking backwards, we have been tripling our compute every single year for the past couple of years, and we've also tripled our revenue. And the thing that we find within OpenAI is every time we want to release a new feature, we want to produce a new model, we want to bring this technology to the world, we have a big fight internally over compute, because there are so many things we want to launch and produce for all of you that we simply cannot because we are compute constrained. And I think we're moving to a world where GDP growth will itself be driven by the amount of compute that is available in a particular country, in a particular region. And I think that we're starting to see the first inklings of this. And I think over the next couple of years, we'll see it start to hit in a real way. And I think that AI is something where I think data centers can actually be very beneficial to local communities. I think that's a really important thing for us to really prove to people. But also the AI technology you produce, that is also something where, in terms of scientific advances, you think about what has been the most fundamental driver of increase of quality of life, right? It really is about science. And every time we've gone into specific domains, you just see how much limitation there is from how things are done, because that's just, there's a particular discipline that's built with a bunch of expertise, there are a small number of experts, and that it's hard for them to propagate that to future generations. For example, in biology, we hooked up GPT-5 to a wet lab setup and had humans described what the wet lab looked like. The model said, here are a couple of ideas to try. The humans would go try it, and it actually produced a 79x, almost 100x fold improvement in the efficiency of a particular protocol. And that's just one particular reaction that people have spent some time actually optimizing, but not a ton of time, because it's just there's so much surface area available in biology that no human can possibly get to all of it. No human can be an expert across every single subfield. And I think what we're going to see is AIs that really bridge across disciplines that humanity has been unable to bridge, right? You see this within healthcare, where as humans learn more, we specialize more, but we're going to have AIs that are going to amplify. And so I think it'll be for hard problems that AI will be brought to bear. This will be true for enterprise. Every single application, I think, will have an agent that is accelerating what people want to do. And I think the hardest problem for humanity will be deciding, how do we use the limited resources we have to get the most benefit for everyone.
That is an incredible vision, Greg. We are so excited to be working with you. I think there's no question in the world that we have the power to really change people's lives. Thank you for the partnership and really look forward to it.
Thank you.
Amit Jain, CEO and co-founder of Luma AI, presented Ray 3, the world's first reasoning video model capable of generating 4K and HDR video, discussing their growing partnership with AMD.
So at Luma, we are training these systems that simulate physics, causality, are able to go out, do research, call tools, and then finally render out the results in audio, video, image, text, whatever is appropriate for the information that you're trying to work with. In short, we are modeling and generating worlds. So as an example, let me show you some results from our latest model, Ray 3. By the way, Ray 3 is the world's first reasoning video model. So what it means is it actually is able to think first in pixels and latents and decide whether what it's about to generate is good. And it's also the world's first model that can generate in 4K and HDR. So please take a look.
When you close your eyes, what do you see? When we talk about reality, how do you know what is real? Or what is simply your imagination? Now open your eyes.
I could say, Amit, that looked pretty incredible. So tell us, how are customers using Ray 3 today?
So we are working with very large enterprises as well as individual creators across the spectrum. And we work with them in advertising, media, entertainment, and industries where, you want to tell your story. 2025 was the year when they started to deploy our models and experiment with them. And towards the end of it, we are seeing large-scale deployments where people are using our models for as much as actually making a 90-minute feature-length movie. What customers are also asking us a lot for, as they're using it more and more, is control and precision. How can they get their particular vision out onto the screen? And what we have realized, and through our research, is that control comes from intelligence, not just better prompts. You can't keep typing in again and again and actually do those things. So we have built a whole new model on top of Ray 3 called Ray 3 Modify that allows you to edit the world. So let me show you actually what that looks like. This won't have audio, and I'm going to tell you a little bit about what you're seeing. So what's playing on the screen is a demo of Ray 3's world editing capabilities. It can take any real or AI footage, so footage from cameras or footage that you generated, and change it as little or as much as you want to realize the creative goals. It's a powerful system that we have developed for our most ambitious customers who are most demanding, and they spread the gamut across entertainment, advertising, and this has allowed us to enable a new era of hybrid human-AI productions. The human becomes the prompt through motion, timing, and direction. You act it out, and then the model can produce it. What that means in practice is that filmmakers and creators can create entire cinematic universes, now without elaborate sets, and then edit and modify anything to get to the result they want.
The keynote highlighted how AI is enhancing personal computing, making devices smarter and more personalized. A new development in AMD's AI-powered processor for PCs was introduced.
Again, with our next-gen Ryzen AI notebook and desktop processors. So today, I'm proud to announce the new Ryzen AI 400 series, the industry's broadest and most advanced family of AI PC processors. Ryzen AI 400 combines up to 12 high-performance Zen 5 CPU cores, 16 RDNA 5 RDNA 3.5 GPU cores, our latest XDNA 2 NPU delivering up to 60 TOPS of AI compute, and support for faster memory speeds. These flagship Ryzen AI mobile processors deliver significantly faster content creation and multitasking performance compared to the competition. Now, there's a lot of excitement for the Ryzen AI 400 series, and if you're walking around CES this week, you're going to see many notebooks launching this week. The first Ryzen AI 400 series PCs begin shipping later this month, with more than 120 ultra-thin gaming and commercial PCs launching throughout the year from every major OEM across every AI PC form factor.
The potential of AI in machines that see, decide, and act instantly was explored, along with its application supporting a permanent human presence on the moon with Blue Origin.
AMD technology is powering critical space missions today, from delivering satellite internet connectivity to remote communities, to enabling autonomous exploration of Mars, the moons of Jupiter, and beyond. On Mars, AMD Adaptive Computing enables the Perseverance rover to operate autonomously. That same technology is also powering robotic systems at NASA, JPL, and both the European and Indian space agencies, delivering reliable compute in some of the harshest and most unforgiving environments. One of the leaders in space exploration and a company using AMD technology to help build the next generation of spacecraft and lunar infrastructure is Blue Origin. Please welcome John Koulouris, Senior Vice President of Lunar Permanence at Blue Origin, to the stage.
Hi, Lisa.
John, thank you so much for being here. You know, Blue Origin is doing just some amazing things. Talk to us a little bit about your mission and what you're working on.
Yes, thank you everyone for having me here. I'm very excited to tell you about what we're doing. Jeff Bezos, our founder, likes to say that Earth is the best planet in the solar system. It's sustained life for millions of years. And as we explore the solar system, Earth will be the origin of that life, that pale blue dot that is Earth. And that's why our company is named Blue Origin. To protect that planet, we want to move heavy industry eventually off the Earth as we look to build things such as solar power satellites in low Earth orbit, settle the moon, settle Mars, explore the asteroid belt. We'll move on and we'll build that infrastructure so that eventually millions of people will be living and working in space for the benefit of Earth. And that starts with one person. Originally, we had Yuri Gagarin and Alan Shepard explore. Then the Apollo astronauts. Then just recently, the International Space Station celebrated 25 years of continuous human presence in space. The next step for us is lunar permanence. And our business unit that I'm lucky enough to be a part of is named Lunar Permanence specifically so that everyone knows immediately what we're trying to do, is establish a permanent presence of humanity on the moon.
AMD's involvement in the Genesis mission and commitment to investing in education for the future of AI were highlighted.
Going forward, there's a lot more that we can do to power the future of scientific discovery. We are actually working very closely with the US Department of Energy and America's national labs as part of the Genesis mission. Genesis is a national program launched late last year to accelerate the convergence of AI, supercomputing, and quantum computing. Together with Oak Ridge National Labs, we recently announced 2 new supercomputers that are part of the Genesis mission. The Lux computer, that is the first dedicated US AI factory for science that will come online early this year. And Discovery, the next flagship supercomputer planned in 2028. Genesis is the most ambitious public-private technology initiative in decades. Leading this historic effort is Michael Kratsios, who has shaped national policy at the highest levels as a former US CTO and Undersecretary of Defense for Research and Engineering. Please join me in welcoming the President's Chief Science and Technology Policy Advisor, Michael Kratsios, to the stage. Michael, thank you so much for being here. I know just how busy you are. You've described this Genesis mission as a real moonshot with the largest mobilization of federal scientific resources in decades. Can you talk a bit about why Genesis is so important?
The Genesis mission is a great example of how President Trump has moved fast in less than a year in order for the US to lean in and win the AI race. Genesis is the largest marshaling of federal scientific resources in recent history, and at a scale and an urgency at the Apollo mission or even the Manhattan Project. We are bringing together the unmatched power of our national laboratories, supercomputers, and the nation's top scientific and innovative minds with the goal of doubling the productivity and impact of American science within a decade. This whole of government approach represents a historic mobilization of resources, tasking the Department of Energy to integrate its world-class supercomputers and data sets into a unified, closed-loop AI platform. Integrating this data, the Genesis mission leverages the power of AI to automate experiment design, to accelerate simulations, and generate predictive models that accelerate federal R&D productivity.
AMD's presentation also revolved around more AI, emphasizing its focus from promoting AI performance to showcasing practical AI applications at scale, moving from zettaflops of data focused on AI to yotaflops of data focused on AI. AMD is actively incorporating Copilot Plus capabilities into desktop systems, not just mobile, initiating a new refresh cycle for commercial and prosumer uses. High-profile endorsements from Microsoft, OpenAI, and Blue Origin reinforced AMD's standing in the AI landscape. While I enjoyed both keynotes, I must admit that I might be biased due to witnessing them live. In comparison, I found NVIDIA's presentation more impressive. The graphics were crisper, the robots were more dynamic, and their AI rack was more effectively showcased. AMD's Greg Brockman seemed a bit nervous, which was unfortunate. Still, he needed to maintain composure, especially while wearing a leather jacket like that. And as I mentioned, if you're showcasing a robot at CES, it should exhibit movement. Their demo did not move at all.
Is this gorgeous or what? Danny, tell us about Gene.01.
So our vision is a future where humans remain at the center, supported by technology. That's why we focus on building humanoid robots that people can trust and accept. For us, acceptability means beauty, grace, and safety. Gene.01 is Italian by design.
Is it really Italian?
Yeah. But basically, what really sets Gene.01 apart is touch. A distributed tactile skin across the robot body allows Gene.01 to feel pressure, contact, and intention-making touch a primary source of intelligence. Just to give you examples why this is so important, in factories, touch makes possible basically to allow human-robot collaboration. And in healthcare, that is going to be pivotal. Basically, a patient can hold the robot and he can feel how to help the patient in the best way. So this enables safer decisions and more natural interaction in the real world, powered by AMD computers platforms. Our first commercial humanoid will be manufactured in the second half of 2026, and we are already working with industrial partners, including a leading steel manufacturer, to deploy these robots in safety-critical environments. Lisa, this is not science fiction, and we're making it happen thanks to you.
Thank you so much, Danny. This is truly exciting. We are super excited about what Gene.01 can do. Thank you for being here.
Thank you.
I even created a quick demonstration using Luma AI to illustrate how it should have been. Although both companies presented GPUs and CPUs, they weren't focused on primarily catering to the gaming community. It's a significant segment of the consumer base represented at CES, that's the C, they seem to market AI more towards investors than everyday users. That's what I felt like. Next year, I might consider skipping the keynotes altogether, as I felt I lost an entire day without gaining much valuable content from my channel.